Welcome to another Mr. Paul video. In today's lesson, we are on 10.3, properties of rotations. Rotations is another math word. A lot of us do understand it though. Rotations is the math word for to turn. What it means is taking a shape and we're going to be turning it like this. Or we might be able to turn it the opposite direction like this. The point is that we're going to take an object like this index card and we're going to be able to turn it in two different directions. So even though it stops at different angles and stuff, it can only really turn two ways. So for example, as it's turning in this direction, we're going to call this counterclockwise, meaning the opposite way a clock would move. Or it could turn this way. This is called clockwise. This is the same way that a clock hand would move, in this direction, counting up from 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So even though it could stop at 6 or 3 or whatnot, we're only focusing on the directions, okay? So in the properties of rotations, also known as turns, this will be number 3 of the types of movement that we're learning. We are, once again, going to be taking snapshots of the before and the after picture. The before, also known as the starting point, the pre-image, is labeled A, B, C, and D. And the after, meaning the ending, is called the image. It's the A prime, B prime, C prime, and D prime. And just like all of the other types of movement, you don't move the center of the object, you move the corners of the object. You move the vertices from A to A prime. If you've seen the previous videos, you'll understand what this means. So let's just take an object, okay, and then we're going to rotate it. So let's just say that we have a triangle like this. It's a small triangle. A, B, and C, and this is our pre-image. And we want to rotate it one of two ways. So we have a direction that goes like this, okay, and we'll call this clockwise, right, abbreviated CW, clockwise. Clockwise is abbreviated CW, and then we have in the opposite, see, this is the way the clock would move, and then we have the opposite way a clock would go, like this, and this is called counterclockwise. Also known as CCW, okay, as an abbreviation. Now, obviously, when we take an object like this triangle here, and then we were just to turn it, no matter which direction, we went clockwise or counterclockwise, you'll notice that it could get very confusing when it turns and it's still located in the same direction. You'll have two shapes on top of each other. It's very confusing. So to solve this problem, mathematicians decided to rotate it around a point, a fixed point, such as this. And they will rotate it around that point. Now, oftentimes, this point is defined in a given space. And the very typical one to do is to think about a graph where the point that you're going to be rotating around will be the origin of a graph. Now, when rotating this object, we're going to be rotating it not around the center of the object, meaning we're not going to take the object and turn it. Instead, we're going to take this object and then turn it around the axis. Okay? Which means, imagine we have a index card like this, and rotating it around the object, like around the center like this, or like this, or like this. Each time moving it 90 degrees. Remember, 90 degrees is like an L. So each time we move something 90 degrees, we'll be moving it one quadrant over. Well, it's almost as if we're taking this entire piece and then turning it. So let's just focus on what would be called a direction this way, right? A counterclockwise. We'll say 90 degrees, counterclockwise. We're going to make one turn, right, 90 degrees, which is just one box over, counterclockwise. So how do we do that? Well, we need a point of reference. So let's just say A, okay? This point of reference is A. I'm using this as a, to mark where A is compared to this part of my axis, right? The positive y-axis. If I were to take this entire axis and then turn it this direction one time, like this, you'll notice that this axis becomes here. This is, let's just say, 2 spaces away. It means that about 2 spaces away from here would be A prime. I know it's a little hard to imagine, but if C is about 3 spaces away from this location, it will now be 3 spaces away from this location. This is C prime. And B, I don't know, is about 6 spaces away from this location. Then it'll be about 6 spaces away from this location. And be called B prime. Now on graph paper, this is a lot easier because this point of reference might be a number, like say 5. And I can measure the distance how far away it is from 5. So this distance would be the same away from this 5. This distance might be a 2, and this distance might be a 3. And I can measure how far away it is from the 2 and the 3 as if this entire axis moved one time counterclockwise. However, if I move each vertex, I've now moved the entire object 90 degrees clockwise. It's almost as if you took this entire paper and turned it one quarter turn, and this is now the image. We can do another example, and this time we will say create some axes here. And here's the center. And we'll make our object look something like this, right? Maybe this time it's a rectangle, but it's really close. It's really close to the positive x-axis, really close to the positive x-axis. This is A, B, C, and D. And this time I want to rotate it 2 times. Okay, this time I'm going to rotate it 180 degrees. That's 90 plus 90 in clockwise, meaning one turn this way, another turn this way. It's almost as if we grab this axis here and then turn it once to become this axis and 2 times to become this part of the axis. So a shape that's up here would be located here and then here. Now, all we need to do to rotate it is find a point of reference. So for example, this spaces on this axis, if turned twice, would become this space and this space. Let's just say this is one away from here, one away from here, which means that I would have one away from here, one away from there. Where D is flipped to here, so this is D prime, and C is rotated to here, this is C prime. A, we'll say is, I don't know, 2 away, 3 away, which means there would be 2 or 3 away here and 2 or 3 away here, where C and B prime, D and A prime. If you moved each individual vertex, you've moved the shape. It's almost as if you grabbed the paper and turned it 2 turns. Remember, each turn is 90 degrees. 2 turns the way that a clock would go. Okay? This is a whole lot easier to demonstrate on graph paper, but unfortunately, distance learning doesn't have graph paper. So this is more of a conceptual video where we're taking this and turning it 2 turns this way. And this video, or this one, we're turning 1 turn this way. That's all for today's video. I hope these are helping. That's the last video that I'm going to be recording for you guys. I don't know. Peace.